So welcome to the object-oriented programming with TypeScript sections. One of the core features of TypeScript is that it supports classes and interfaces. This gives us a great way to organize and structure our code. In TypeScript, we define classes just like we do in JavaScript, but with additional features like typing. A class is essentially a blueprint for creating objects. Let's go ahead and create a class. So I'm going to create a classes.ts and create a class called person. All right, we are getting some red squiggly underneath, and if I hover over, it says duplicate identifier person, and variables.ts also has a person variable defined. So even though our tsconfig.json says we are using modules like module common.js, TypeScript doesn't fully treat our files as separate modules unless we explicitly use import or export. So neither variable.ts or classes.ts used export or import. So TypeScript assumes they are part of the same global scope and it gets confused and hence throwing this duplicate error. The fix is easy. We just need to tell TypeScript that this file is a module by prefixing this class with export syntax. Now TypeScript knows person only lives in person.ts, and if I want to use it elsewhere, I'll have to import it. So no more naming conflict. All right, that got rid of the issue on person. What is going on here? Property name has no initializer and is definitely not assigned in the constructor. So we haven't reached the constructor part yet. Here TypeScript is being super cautious. It wants to make sure that all class properties will have a value by the time the object is created. Since I didn't give name a value right away and I didn't assign it in a constructor, TypeScript assumed it might be undefined, and that breaks the strict property initialization rule being introduced because of the strict mode in tsconfig, but that would go away by the time I reach the constructor stage. So let me write the complete implementation and then we'll see. Right, we are done. And in this example, the class person has two properties, name and age, and a method greet that returns a string. The constructor method is used to initialize the object when it is created. Constructor method is a special function within a class. It runs when an instance of the class is created. Here's how we can create a new instance of the person class. So outside the person class definition itself, I'm going to say const person1 equal to new person Alice and 30 and console.log. So when we create a new object, we pass in the values for name and age. The greet method then uses those values to output a greeting. When we do new person, it would automatically call this constructor function and pass in those arguments. So as you can see in this example, classes in TypeScript can have both methods and properties. Methods are functions that belong to a class, and properties are variables that store data for each instance of the class. Just like how a person has a name and an age, each instance of the person class has its own name and age property, which are unique to that instance. The method greet allows the object to behave in a certain way. Now let's talk about inheritance. Inheritance is one of the pillars of object-oriented programming, and it allows one class to inherit the properties and method of another class. So here we have created an employee class that extends the person class. One second. The employee class inherits all the properties and methods from person. We also added a new property job title and a greet method that extends the functionality of greet method of person class. Think of it this way. A person is like a general blueprint for any person, but an employee is a special type of person with the additional property of job title. So an employee inherits all the basic properties of a person, but adds something new specific to them. So here, once the constructor of employee is called, it first calls the constructor of its parent, that is the person class, with name and age, since it only takes two parameters. And then it assigns the job title parameter to its job title property. In greet function, it is returning super.greet, which is going to return, hello, my name is this and I am this years old, and it's suffixing it with I work as a job title. So let me quickly try it out. Right, let's give it a go. Something went wrong. Oh, I forgot the parenthesis. All right, here it goes. Hello, my name is Joe. I am 40 years old. I work as a supervisor. Perfect. All right, next we'll discuss interfaces. An interface in TypeScript is like a contract. It defines the structure of an object, including what properties and methods an object should have. Let's create a simple interface. This interface defines the shape of an object that has a name property and a greet method. Any class that implements this interface will need to provide these properties and methods. To implement an interface, we use the implements keyword. Let's implement the greetable interface in a class. Cut this to put it in its logical place, and I'm going to make the class person implement this. Here we go. We made the person class implement the greetable interface, so it must have a name property and a greet method. By implementing an interface, we ensure that our class follows the structure defined by an interface. If we try to add or remove a required property or method, TypeScript will give us an error. For example, if we remove the greet method from person, TypeScript will throw an error because person no longer satisfies the greetable interface. Let's see. So I comment this out and we are getting this error. Class person incorrectly implements interface greetable. Property greet is missing in type person but required in type greetable. See? Okay, gotta bring it back. So interestingly, interfaces can extend other interfaces, just like classes can inherit from other classes. So let's extend the greetable interface to create a new interface, employee greetable. I'm going to say, all right, here employee greetable extends greetable, adding the job title property. So if I copy this and make the employee class implement employee greetable, now the employee class implements employee greetable and extends person, ensuring that it has both name, job title, and the greet method. Now let's move on to some advanced object-oriented programming concepts in TypeScript, starting with abstract classes. So abstract classes are classes that cannot be instantiated directly. They are meant to be extended by other classes. An abstract class can contain abstract methods which don't have any implementation but must be implemented by its subclasses. So in this example, the animal class is abstract, meaning you cannot create an instance of animal directly. It has an abstract method make sound that is implemented in the dog class. The move method is implemented in the animal class and is available to all subclasses. And no, I don't know what does a fox say, so I'll stick with the dog's example only. Right, so the abstract methods in an abstract class defined using the abstract keyword are like promises that subclass must fulfill. They define a contract but leave the implementation up to the subclasses. As mentioned earlier, you cannot instantiate an abstract class directly. This would give us an error. So if I try to do const animal equal to new animal, you see there's an error. Cannot create an instance of abstract class. That wraps up our discussion of abstract classes. Next are visibility modifiers. So visibility modifiers in TypeScript are used to control the visibility of properties and methods in a class. These modifiers are public, private, and protected. Think of public as something you are allowed to see and interact with, like an employee's name tag. Private is something you can't see, like their salary. And protected is a middle ground, something that can be seen within the class or its subclasses, but not outside of them. Let's take a look at an example. So in this example, the name property is public, so it can be accessed anywhere. The age property is private, so it can only be accessed inside the class. And the job title is protected, so it can be accessed inside the class and in any subclass. So let me show you with an example. As you can see over here, we can only access the name correctly. We cannot access a person's age or its job title. So to get the person's age, we can use this getAge function, which has access to the age property, and this is the preferred method for doing such operations. Job title would only be accessible to the methods of protected person or any class that extends protected person. I hope that part is clear. All right, finally, we can move on to static members. So static members are special because they belong to the class itself rather than instances of the class. They're useful when you want to share functionality or data among all instances of the class. So let's look at a static method. Right, so in this example, the add method has the static prefix. So you can call it on the class itself, not on an instance. So let me show you how. So as you can see, we did not create any instance of the math utility using new math utility operation. We are calling the add method on the math utility directly. And this is going to output 8 to the console. This, you can see 8 being logged to the console. Static properties work the same way. They belong to the class, not to any instance. The most popular example for that is a counter. So let me show you. So here we are using a static property count that keeps track of a value shared by all instances of the counter class. So anytime I use counter.increment, the count variable would be incremented and you will see its value over here. So if I do this, you can see 1, but if I copy and paste it 2 times, then you're going to see 2 being logged to the screen. Right? So today we covered a lot of important concepts in TypeScript's object-oriented programming model, including classes, interfaces, inheritance, abstract classes, visibility modifiers, and static members. These concepts are the building blocks of writing clean, maintainable, and scalable applications using TypeScript. By the time you have seen that there's so much content to cover in this crash course that we are having to rush past every concept. So I hope you are understanding everything. But if you're not, let me know in the comments and I'll try to help you out as quickly as I can.